Hey, good to see you again. Where to now? What are we going to do with all this algebra? People say, well, I can't see the use of this in everyday life. I'll never use it. So let's have a look at this mess I've created here. I've scribbled all over the page. Look at the things in blue. I think that's where we started, mathematical sentences, or was it the things in black, the puzzles? And we then made mathematical sentences. You might try to do a bit of revision and see if you can solve those. What about those in green there? I think they came up much later with expansions, remembering that if x is a number, we can do whole heaps of stuff with it. The ones that we want to look at now are the ones in red, because that's where the usefulness of algebra for later on can best be seen. All right, so let's have a look at a couple of different areas. We're going to look at some of the red ones where they are useful in things like physics and maybe engineering, electronics later on, and then we're going to look at some of the ones there that are useful in mathematics. And then finally, the one over here in red, which talks about the boss has $1,000, that might be of a more day-to-day use, or more in an economics way, and we'll have a look at that. So I hope by the time we get through, you'll say, hey, I've actually learnt some skills that will be useful later on. So let's go down and have a look. And the first one we want to have a look at is this one here. I don't know what your physics is like at this stage, but this is a formula for the current flowing in the circuit where I is the current in amps and V is the voltage applied to the circuit, and that's in volts, and R is the resistance in ohms. So this is a basic starting one in electrical circuits, and leading on to uses in electronics, of course. Well, the way it's set up, you can see it is quite easy to calculate the current flowing if you put, let's say, 240 volts, which is the Australian voltage, and here, let's say, we have a resistance of 10 ohms, then we would have 24 amps flowing. So that's nicely set up. But what if somebody wanted to say, well, I've got to work out what voltage I have to apply to a circuit so that I get a current of, let's say, 50 amps when the resistance in the circuit is, what can we say? Let's say 20 ohms. So to do that problem, it would be nicer if the formula was set up as a V equals formula. V equals. So we might like to rearrange this formula. Let's go back to our algebra. Hey, that's what it's all about. And up here we could say, well, if we wanted V, what's been done to V? It's been divided by R. To get an expression for V back again, we will times by R. So let's multiply both sides of that equation by R. Oh, now we have a formula for the voltage. So we might say, well, that means that is V, to get the voltage, you multiply the current that you require by the resistance. So here that would mean 50 by 20. We would actually have to apply, what is that? That's 1,000 volts to that circuit to produce a current of 50 amps with a resistance of 20 ohms. So the voltage there would be the current of 50 times the 20 ohms resistance. So rearrangement of a formula can be helpful in science and physics, electronics, if we're wanting to calculate something else other than how the equation is set up. So there's our first little use for rearrangement of expressions in algebra. Let's go on and look at another one now. Do you recognise this formula? This is from mathematics. And if, for example, you wanted to paint the outside of a cylindrical tank, something like this, and you wanted to find, we won't paint the top, it's open at the top, and the bottom's on the ground on a cement base, so we don't need to paint that. We're only going to paint the curved surface out here, or this surface here, we're going to paint that. But how much is there in that? Well, we could uncurve, or uncurl this around here. So how big is that around there? The circumference of that circle is 2 pi r. So if we laid it out flat, we would have a rectangle which would be 2 pi r, uncurling that, laying it flat, and let's say the height of the cylinder was h. So that's where the formula comes from. It's the area of the curved surface of the cylinder. So let's say we wanted to paint that. This would be the formula that we would need. But you could say, well, let's work out the area that we need to make maybe cylinders of different radii. And so, well, if we have them all the same height, we could say, well, I want to know how to work out the radius to give me a particular area and given a particular height. So I want to get an expression for the radius needed. So what's been done to r here? It's been times by 2 pi. It's also been times by h. Let's try to get r back again. Let's divide both sides by 2 pi. And we could do it this way now. A over 2 pi. And if we divide this side by 2 pi, we come up with A over 2 pi is equal to RH. And we can then, reversing this, aren't we? We could divide by h and get 2 pi h equals r. So that would be a convenient formula if we wanted to routinely, or over a number of times, calculate the radius necessary to produce a certain area of our curved surface for a given height. So that's an interesting rearrangement also there. Can we go further? What about this one here? This is another maths one. Do you know what this is the formula for? 4/3 pi r cubed. Well, don't know whether you've seen this one. This is the formula for the volume of a sphere, a ball-type sphere, not a very round one there. So again, we might say, well, if we knew the radius of this sphere, that's the radius, we could calculate the volume by sticking the radius in this position, cubing it and so on. But what if we wanted to do some routine calculations and work out what radius was necessary to produce a certain volume? It would be convenient to have the formula like this, R equals, so that we could just put a volume in and work out what the radius of the sphere needed to be to get that volume. So what's been done to R here? It's been cubed, then it's been multiplied by pi, then it was multiplied by 4 if you like, and then divided by 3. Would you like to think of it that way? So if we want to get an expression for r back again, let's reverse this. Let's multiply both sides by 3. And if we did it over here, let's just check it out. It would cancel. We'd still have pi r cubed. Then we could divide, what's this one here, dividing by 4. So if we divided by 4, we would have 4 divided by 4, that would cancel pi r cubed. And then our next step is to reverse the multiplication by pi. Let's divide by pi, so that's getting a bigger denominator still over here. And dividing this side by pi, we're back to r cubed. And then if we reverse this, what's the reverse of cubing? Let's take the cube root. So we could now set this up as a nice formula designed and geared up to work out what radius we had to make our sphere to achieve a certain volume. So we'd put the required volume in there and then do all of this to it, and that would give our radius required. So you could do that on a spreadsheet then. You could set up the columns on a spreadsheet where you would enter the V values, then put a formula in, and there's your formula. The formula here says multiply V by 3, divide by 4 pi, and then take the cube root, and you'll have the radius that you need to make a sphere of volume V. Now this is going to be important if you want to do many of those calculations. So it's getting interesting, isn't it? Our mathematical sentences may be particular or unique, meaning just a particular number, or they could be more generic, enabling us to set up a general rule for calculating a particular value. Okay, let's come down to a physics one here. I don't know whether you've ever seen this one before. This is, T is the period of oscillation. This is in time, how many seconds it takes, and for a pendulum, so let's have a look here. We have a pendulum, there's a pendulum bob, and when we move it to one side, it swings back through the mean position over here. So the period is the time it takes for one complete revolution back, out there and back again. So the period of a pendulum. This can be used if you want to make a pendulum clock, driving the hands around so that you can work out what length the pendulum has to be so that you produce a certain time going backwards and forwards here in seconds or minutes or whatever. So what about L? What does L mean? L is the length of that line there, the length of wire holding the bob, the little weight on the end. And then G is the gravitational acceleration, which is a constant. So let's say you were a clockmaker using pendulum clocks. They look quite attractive, big old grandfather clocks. And you wanted to work out the various lengths you needed to make the period of the clock a certain amount. So we really want L in there. Now what's been done to L? Well, the first thing that's been done is been divided by G, and then we took the square root of the whole thing. Here we are, we're just going through these. And then we multiplied by 2 pi. So if we want to get an expression for L back again, we need to unpack our present, if you like, reverse those steps. So let's divide both sides by 2 pi. So here it would be T over 2 pi equals, it would cancel on this side and be left with square root of L over G. We now come up and we want to reverse the square root, so we're going to square both sides. So this would become T squared on 4 pi squared, and it will remove the square root from this side, have L over G. And then if we reverse the step up here, dividing by G, let's multiply by G. Gt squared over 4 pi squared would be equal to L. Let's just check over here. If I multiplied L on G by G, yes, it cancels. So now, what have I got? Well, if I wanted to make the pendulum period smaller, like it's going to swing back and forward faster, I could put the value in there and work out what length of pendulum I needed to make the period larger or smaller. So, very useful in maths and physics, electronics in general, to be able to rearrange our formulas, which are only mathematical sentences connecting various properties of a system or variables. And so, are you getting excited? There are some very important uses here. Let's go to one which is perhaps a little bit more like an everyday problem. And here's one here. The boss has $1,000 as a bonus for you. But whatever he gives you has to be taxed at 25%. So how much do you get? Now, your average person would say, well, 25% of 1,000 is a quarter. A quarter of 1,000 is $250. So that's the tax. So you're going to get $750. Wrong. Okay. Now, can you see why it's wrong? Let's have a look, and let's go down and have a bit of room down here. So, let's use algebra to work this out. So what would you do? How much do you get? Let the amount be, I guess you're hooked on X now. Let the amount be X dollars that I get. So therefore, my X dollars plus 25% of that, 25% of X has to total 1,000. Can you see why this one over here is wrong? It's finding 25% of the whole amount the boss has got. You're only taxed 25% of what you get. So you can't actually work it out yet because you don't know what you get. So algebra to the rescue. This line says, I will get a certain amount, which I don't know. Then when I add on 25% of that amount, not of $1,000, then the total must come to 1,000 because a boss only has 1,000. You've got to get the most you can and pay 25% of that to taxation. All right, so let's see if we can do some maths in here now. 25% is 25 over 100 or 0.25. So it's X plus 0.25 of X dollars has to come to 1,000. So what is this? This is 1.25x equals $1,000. Or x is 1,000 divided by 1.25. Too much maths here? Let's have a look. 1x plus 0.25x's. That's 1 1/4, or 1.25x's. And down here, x has been times by 1.25. Get x back again, you'll divide by 1.25. And if you do that, what you have there, you have $800. So, the amount that the person gets, or you get, is $800. Problem solved. And it wasn't 750. Okay? Now, can you see some of the usefulness of algebra? It makes you, or allows you, to actually go through logically and break a problem down. And this is where people in sales and economics find algebra useful, the algebraic way of thinking, to say, well, I've got to go through it in stages and see what's happening and look at a logical analysis of a problem. Obviously, it is very much about X if you're trying to find some unknown, but it is very much about analysis and a way of thinking. So I hope that started you on a very exciting algebra journey later on, and thinking that, gee, I might be able to use this in some interesting spots, whether it be in money or in science or mathematics. So I hope you've enjoyed the presentations. I've enjoyed producing them for you, and so hope to see you again. Cheers for now.